Good morning and welcome to our session. Thanks for joining me today for this session, which is about Amazon DynamoDB key feature that drive business impact. My name is Disha Kamra and I'm AWS Solution Architect and Consultant here in Decode Cloud Solution. In this session, I'm going to discuss some of the feature uh, Amazon DynamoDB customer are using to deliver an optimal experience for consumer of their own products and services. So, the topics that I want to move through in this discussions are initially this list of feature which I'm talking about here, like we will talk about elasticity for throughout and storage, caching, backup and restore option available there, export to Amazon S3. So this list of feature things that you can use to improve the experience for your developers to rapidly innovate and to deliver a better quality of service for your own customer. First up, let's talk about the elasticity around the scaling. It applies to both throughput and storage with DynamoDB. That's really the two fundamental ways that we measure your consumption of the service. So in 2011, when the service went GA, AWS had an initial capacity mode called provisioned capacity mode. In this mode, storage scale automatically. You can only pay for the storage that you are using at the time in gigabytes at an 1 hour granularity. And AWS also allow you to initially describe or provision the throughput that you want to read units or write units. And they are basically like two dial. You can change that to whatever you want to it to be, and the DynamoDB service will scale out your tables partition in the backend to support that level of throughput. In June 2017, AWS added an ability to auto-scale that read and write capacity based on CloudWatch metrics that tell us about your read and write unit consumption. And while in 2018, AWS added an entirely new capacity mode, which is known as on-demand. Again, the storage scale automatically, but the throughput scales will get into 2 times your prior maximum consumption level and your high water, and in this case you do not have to give AWS any signal about how many reads and write you anticipate using, and AWS also don't have to be watching your CloudWatch and metric to determine when how to scale out. In this mode you also per request, so you always at 100% efficiently. Okay, I just want to quickly check with you guys. Hope I'm audible to you. Just give a quick hand raise or just something right over on the chat window. Am I audible to you? Hope you are able to hear me. Okay, I take it as an yes. Thank you. Thank you so much. So coming back to the slide which we are talking about in here. So this is how this, so we talk about the one which was launched by AWS, that's on 2018 on demand. So moving forward, let's take a look at how that looks in terms of DynamoDB when we talk about on demand. So in this graph, we can see some throughput consumption in blue, and the y-axis is the time, and the orange we see the throughput potential of the table, which is really determined by the number of partitions. The same is true for provisioned mode, and these partitions are basically the storage node across which AWS is distributing your data. We can see that as the loads grow and nears the maximum, DynamoDB identifies that the table might need more throughput potential partition, splitting occurs, and we now have a maximum. So the load again reached a new peak and DynamoDB again split the partitions to increase the potential of your table. Each round of splitting can take around half hour, but typically much less than this. So each partition is continuously analyzing the throughput it is serving and the way your traffic is distributed across the data. It's make intelligent decisions based on this. Notice that while our load sometimes drop to zero, the potential of the table never decreases. We are not paying for any consumption or any provisional level of throughput, but when the load return, the on-demand table is able to cover it 100% utilization efficiently. So on-demand throughput sounds magical, doesn't it? So there are some infrastructure associated with delivery this experience and that is built into the pricing for on-demand capacity. So currently you can read 1 million 4 kilobytes item with strong read of the write consistency in US East 1 for 25 cent, and there is a tendency for some to compare that this is the pricing of provisioned capacity and to conclude that on-demand is comparatively expensive in making the comparison and assumption of 100% utilization efficiency, which is often made of the provision capacity, but it is not really achievable. AWS offered the choice of capacity mode because load pattern vary and so do the business priorities. I'm often asked how to choose a capacity mode. So before we dig into this question, we should know what is the difference between a price and a cost. So price is what? What AWS charge customer to use their services. Cost include the time of your technical resources. So adjusting an auto-scaling policy and smoothing things out to get best utilization in provision mode takes time and should be checked and maintained periodically. Recognize that this is the time that could potentially be spent working on things that deliver greater values to your customer. Reducing the complex part in the operation and also minimizing the risk and tend to improve the availability. Some companies have large number of DynamoDB tables and supporting a multitude of microservices, and many of them bring very low throughput, perhaps even development or the test environment which see only a few activities, and where I encourage most of the customer to establish a threshold for throughput spend. So maybe for you it's $500 for a month, but if your table would consume less than this threshold in on-demand mode, simplify your operation is likely worth the price. Additionally, consider the life cycle of your data. Perhaps your table sitting around and you need to keep the data, but you are not reading or writing anything. So the minimum for provisioned capacity is one read unit and write unit. You can element the throughput spent by switching to on-demand, and on-demand is the right choice for most of the DynamoDB tables. Prioritize the time you spend in maintaining the optimal auto-scaling policy, and it's turn out the mature workload tend to have more predictable lot patterns. So this is what we are mentioning in this slide, that work on the data consumer, optional load and risks, and how to reduce their resource, your life cycle and utilization. Now let's move along to the caching. The DynamoDB Accelerator, or we call it as DEX. DEX is a fully managed, centralized in-memory caching solution for DynamoDB data operation. It's deployed as a cluster of instant, as you are able to see in here in the slide, in your VPC, and then available to your clients within the VPC within an IAM policy. So DEX is fully API compatible with DynamoDB, so clients need only initialize a session using a DEX driver instance of normal DynamoDB SDK session, which is initialization. From there, all the regular DynamoDB API action and SDK function for the data operation are the same. DEX is a read-through cache, which means that your client does not need to manage populating the cache on the side, and you can write through DEX, in which case you are writing on a synchronizedly pass through the DynamoDB in order to automatically update the cache with any mutation, or you can write around DEX and just rely on the next read through DEX to populate the cache. So strongly consistent read are also passed through DEX, and they do not update the cache. The cache data is expired according to the configurable time to live, and it will also apply a least recently used algorithm to the oldest data from the cache if it fills. So AWS recommend that production use cases always deploy with at least 3 nodes of DEX cluster distributed across 3 availability zones in the region. You can scale out of the 10 nodes to serve the additional read traffic, and you can scale vertically by node type for higher write activity, the larger cache, and the greater CPU capability. While DEX in 3 availability zone configuration is highly available, AWS recommend that you build your application workflow to allow for configure fallback to work directly against the DynamoDB, and should you need to restart or replace your DEX cluster. The benefit for caching can be significant, but an overload or unavailable cache can cause many effect within the complex microservice architecture. While we are not covering microservice architecture here in this session, but you may go and see a few of the previous recording, and there are more coming on your way on the upcoming weeks. So plan ahead and build in levers. Follow your operational best practices for monitoring and scaling your cache. There is an excellent articles available in Amazon Builders Library, which is called Caching Challenges and Strategies. So you can go and have a look on that if you really want to understand how things to be taken care in a detailed manner, because we cannot cover almost everything in this 45 minutes of session. Now, for read heavy workload, a properly configured DEX cluster can offer very high cache hit rate, reducing DynamoDB's already low latency to sub-milliseconds, and it can reduce the number of read unit consumed for the DynamoDB table or secondary index, which will lower your bills per half enough to move them, cover the price of the DEX cluster, and finally it has the impact of smoothing the distribution of traffic across the item in your DynamoDB table. The diagram here shows this effect where items which are running hot do not see notably higher reads against the DynamoDB itself. So, to summarize, for a read-heavy workload which tolerates eventually consistency, you should consider the potential benefit of DEX. And what are they? Lower latency, which has a which will give a really a good experience and will bring more delightful customer experience. Then smoothing of unanticipated skew in the data pressure, which is always be one of the tension for our customer. Then less read units consumed, zero improved is the cost efficiency. Now let's cover some backup and restore feature. DynamoDB provides you 2 backup features. One which allow you to snapshot your table and indexes and keep snapshot, and the other one is point-in-time recovery, which is well known as PITR. This is a feature that I really want to cover in this session. So PITR keeps 35 days of your table history available for restore, so you can fully recover your data to any second in the preceding 35 days. And AWS recommended to use PITR for all the production tables storing data, which is not and or easily recreated. So this point in time recovery do not use your table throughputs and has no impact on your live data operation when we are talking about. So you can see in my screen that there is an option available in the console window where you can enable, you can disable, and it is highly recommended as I told you. So restoring a new table with second is on a click. There will be no impact on your live data. You cover your table deletion and corruption risks as well in there. Okay, guys, before we have something in here, I just want to quickly check. I hope you are able to follow me. A quick check, a very quick check. Okay, I take it as an yes. So let's get started within here. So when we talk about point in time recovery, what are the restore scenario? So access to the access to DynamoDB table is denied by default, and best practice is to allow access according to the principle of last fine-grained control to items even per attribute is available via your IAM policy. And the various data operation can be allowed or denied based on the number of powerful conditions. Despite all of this, it is possible that the malicious individual could delete a table or modify your items. Such a scenario could be also be the result of the simple human error or the coding error. How might this impact your application or service? How would you recover, and how long would that take? Here's what are the restore might look like in the DynamoDB console, which I'm showing in a screenshot. You can see that I must name a table to restore that, and that table must not exist. I get to choose any second in 35 days of Windows to restore from, and I can choose whether to restore with or without any secondary indexes. If the application is being taken down during the recovery, it might be possible to delete the original table and restore to the same table name. But it is very much more likely that you want to keep the original table and possibly keep operating in a degraded state during the recovery. So you will choose a new name for the restore table. Sometime like sense of relief might be appropriate. And now if you made up the table name configure in your application, you can roll your operation into newly restored table. Or you can roll out updated code which builds in a comparison against the restore table items. Each time you access an item in your live table, sort of a repair on an access procedure, you could also search through the restore table and make a comparison to the live table as a backfill type of approach. Lots of possible paths here, and which is the best will be the specific to the use case, and the recovery scenario will be like in DynamoDB stream might provide an additional option capture your change data with a new and old image and stored in S3, and the query it using Athena. Sometime to consider when you are defining your schema, things about binding an attribute which can be used to determine items and to be rolled back. So here we are talking about the following scenario in here. So this might be a stamp, or this could be a version of your application software. And when we considering, let me quickly change the slide in here. So when we considering data protection and disaster recovery, we generally want to define a recovery point objective. How much data am I willing to lose in restoring the service? A recovery time objective how quickly I can recover with point in time recovery. Can be 1 second, or it can be where a table restore takes, and sometimes. But see our recent things about improvement around the shorter and more consistent time, which AWS keep on announcing timely to complete the restore. So like in the previous slide, we were talking about how to manage your application through a recovery in a use case specific. Ideally, we would have a full set of the run book for various scenario, but it turns out that the business continuity and disaster recovery can be difficult and typically not frequently tested. I would suggest that no matter how prepared you are, having point in time recovery enabled will give you option that you may be glad to have in your back pocket someday. So you should consider the value this adds for the critical business functions you build around DynamoDB. And one more thing to note here is, before I move on, when the table with point in time recovery is deleted, the point in time recovery data is also removed. However, before deletion of such a table, DynamoDB will automatically capture an on-demand backup of the table as it existed at the time of the deletion request was made. So this backup data is retained for 35 days and is system owned. It cannot be removed before this time, and elapsed will be provided. You might like to make a policy of enforcing point in time recovery enabling ban on all the important tables. So AWS config may help you here, and deny point in time recovery disablement attempts via IAM monitor cloud trial for denied. So request to delete DynamoDB tables and denied request to disable point in time recovery will, when it's come to the critical protection table, then it is very good thing that you are taking care of the things on in there. Moving to the next slide in here. So, all right, a new feature that I want to cover really quickly is export to Amazon S3. This is released just a few months ago. I'm talking about 2021 itself. Okay, so let me take you in the upcoming slide in here. So it is basically allow you to recover from your point in time recovery backups and into S3. So you name a particular bucket that you are interested in using, and you get to choose the output format that can be either DynamoDB JSON format or Amazon Ion formats. And in both cases, the output will be compressed objects in S3, and so you can choose any second in that point in time recovery window. Typically 35 days is what provided, and this functionality is really nice because we have seen a lot of people who have some kind of regular ETL process where they want to export the data, and we had some tooling to help accomplish that. We have glue and we have data pipelines, but this provides you an ability to actually make the export without scanning from your actual live operational table. It consumes no read units. There is no additional load on your table, and it takes advantage of that point in time recovery data. So if you were not aware of this feature and you do have some kind of a workflow where you are exporting your table data to S3, then take a look at this. It will probably be a much easier for you to take care of. So let's move into the next slide. Wow, this is a great new feature, which is a particle support, and it's give me a minute. Let me take you to the next slide in here, where we are talking about. So Particle is an open source query language which is SQL compatible but builds in support for various level of your structure in your data right from the start. And you will what we have done, what AWS providing is in here, that many customer told them that sometime that slow them down when they want to build around DynamoDB, because many of them are familiar with SQL but not very familiar with DynamoDB APIs. So what is there? They wanted to be able to describe their data operations using something that they are familiar with. So using the particle support in DynamoDB, you can do now or you want to do, as you can see in this example here, just like a simple SQL query. The new console, you can execute these query against your DynamoDB tables. So it is important to note that that does not magically turn DynamoDB indexing into something that supports complex ad hoc reporting types of requirements. But what it does allow you to do is to do the same kind of indexing and data operations as DynamoDB supports naturally, and to describe it in a SQL form that's familiar within there. So let me take you in here. So I have mentioned Particle is an open source specification, and it's meant to be really able to use across many different data store. You will see support for it a number of different AWS services. We wanted to add this for DynamoDB also to provide a nicer end-to-end experience for the customer. So it initially implemented with three new DynamoDB API actions: execute statement, batch execute statement, execute transaction. And it support statements including SQL verbs of insert, update, select, and delete. So you can build a particle statement which you then provide to DynamoDB using that execute statement API, and that will make the particular query that you are looking forward for. If you want to able to batch those query, you can use the batch execute statement API action, which I have mentioned in this slide. Or if you want to do the using DynamoDB transactions, then for the multi items, it will be also for the item potentially grantors, and that provide you to use the execute transaction API. So this is actually really new and very exciting. We think that this will really help developers to learn to adopt DynamoDB more quickly and check out the other options. So let me take you to the next slide, which is talking about the multi-reason architecture. So when we talk about multi-reason architecture, so here we are talking about the global tables features, which allow us to provide a service managed means for the replication between the DynamoDB tables in multiple regions. The table in each region operates like any other DynamoDB table and delivery high availability via storage in 3 availability zones. So the normal DynamoDB regional endpoint is used to access the global table, and regional replica in that region, there is a 4 nines SLA on availability in each region, which extend to the 5 nines. When you build around a global table configuration, then you are talking about replication between the regions in eventually consistent and multi-directional the servers take care of. So it's conflict resolution via the last time when policy, and many customers use global table to enable them to fail their application between regions, allowing them to achieve a higher level of availability. So other are primarily looking to provide a low latency experience for users who may be located in multiple geographical regions, and global tables can also provide a means to meet regularity and requirement, which is a compliance in there. So to meet the requirement, what does the multi-reason architecture backed by the global table looks like? There is sometimes a tendency to imagine a scenario where an application stack deployed in US East 1 and might want to fail over to the different region of the global table. In the event that there is a DynamoDB service impact in US East 1, in fact, the multi-region architecture we see around the global tables involve a complete application or a service stack in each region. So a failure could result from any part of the stack, and a complex system of the multiple components is far more likely to see a failure than the DynamoDB endpoints within a region. Here's an example where a customer application is made up of 3 different microservices. They decide to operate in both US West 1 and US East 1 to give the lowest latency for user on both coasts, to allow for continued service, and should there be an impact of one of the microservices in either regions. So anything looks good here, and but then something went go wrongs in microservice C within US West 1. That might be due to the regional problem in one of the AWS services. That microservice C is built on, it could be due to a software problem in our new deployment of the microservices C, or in any case, our metrics and alarms are telling us that there is a problem with microservice C in US West 1. So it is down. So microservice A and microservice B are seeing a high error rate when they call microservice C to work upon on. So based on this, we fail out as US West 1, and we direct our West Coast user to the application stack in US East 1 instead of how this is work on. So how do customer manage the flow of the traffic for their application? There are many options here depending on the data operations required and the business requirement around the multi-region storage. So a customer may choose to run all reads and writes to a single region, and an active passive configuration which gives them the options to scale out the application in a standby region. So when required, this is the simplest approach for the business continuity and disaster recovery, and it is easy to reason around matters of the data integrity, which we are talking about in here. Another option we see that most of the people choosing is to make all right and strongly consistent read in a single region, but for eventually consistent read with the lowest possible latency, the read or from their closest region. And this is also easy to reason around in terms of data integrity. Uh, to me, the most interesting architecture is an active-active configuration where reads and writes are made in multiple regions, and if your data operations are item-potent, such as an append only a table or unconditional updates, this is easy to achieve. Okay. But due to the eventual consistency of the global table application between the regions, we need to be more careful when using conditional flows. The conditional writes is in an automatic locking pattern or in multi-item transactional read. We need to be careful to make all the right operations behind these activities in a single region. And when we talk about that, it doesn't necessary that to have to apply it at full table level. It's really applies by item. for many business needs. It's possible to be pin items to a particular region, and some items might be homed in one region and other could be homed to the elsewhere else in the. Perhaps the primary key is named according to the prefix, and IAM can allow or deny write activity in the region based on this, or you can maintain an attribute in each item which indicates the home region. And your write operations can be conditioned on this being you can call the local, and you may able to carefully rehome items. So imagine a user profile for a mobile game. Just imagine that the user might normally be in the US but perhaps took a flight to Europe to vacation, and their user profile item might be rehomed to follow them. Or you might forcefully rehome items for a particular reason if you need to fail out of that reason. So these are application level workflow, and it's considered to the possibility for each particular use cases. So most of the traffic distribution requirement are solved with either manual or automatic changes to the domain name and the records using the Route 53. So depending upon your use case, you might be able to leverage health checks and use routing policy based on the latency or geographical location. Or if DNS is not reactive enough for your need due to the potential for the client cache, then you might like to look into the global accelerator, and it can provide latency benefits also. Finally, if you have something like a mobile application, the client could potentially access the DynamoDB endpoints directly based on the Route 53 policy, and could use the federated authentication and fine-grained access control to limit access. In such a configuration, I might recommend you to architecting with API gateway serving the client instant at it's allow for the rate limiting and caching, and take a look at the API gateways integrated DynamoDB support. So for an example of global tables implementation, again, check out the Disney Plus thing. Okay, you can go to AWS reInvent and check the presentation in there. It will help you to understand if you are not able to get an idea about the traffic distribution. Moving to the next slide in here. So, all right, some more new functionality that I am going to share with you around streaming of change data. So in DynamoDB, we have always changed outer capture, or we have long had through DynamoDB streams. Initially, every mutation in your table, when we talk about an insert, update, or delete of any record, it's going to be reflected in that DynamoDB stream. And the DynamoDB stream offers strictly once, always complete, and strictly ordered by updates for a particular item. So when we talk about ordering in the stream, you can then process from the stream using the Kinesis clients library. It's compatible with the KCL, which is, or you can use the triggered lambda function to pull for changes over that stream and then process them accordingly. So we see a lot of different use cases around this event driven and processes. So this is the event driven processes replication. If you want to pushing things into S3, perhaps you wanted to maintain a complete log of all changes. One of the things that we noticed was that many customers were actually using a triggered lambda function and then reading from the DynamoDB stream, one of the best practices. So only then place it back in the Kinesis data stream. And this could be for when we talk about ease of the integration with things like Kinesis data analytics, or to then feed into the Kinesis data firehose. Okay, so or it could be that they wanted to the additional clients and be able to have some fan out there. So rather than let's customer have to solve for that themselves, AWS recently announced a support for the change data capture into the Kinesis data stream directly, and this can be configured for your DynamoDB table independently of the DynamoDB stream. So you can actually enable both of these features which I'm talking about in here. So this make things very much easier to capture all of your updates directly to Kinesis. It also means that you can have a single Kinesis data stream where perhaps you are capturing the changes from the multiple DynamoDB tables and perhaps even other event sources. So let's move into the next topic in here. So while we are talking, one of the very common patterns that we see for use of streams, here we are talking about the materializing additional indexes and additional views in different technologies. Now, this is often in this kind of a pattern where we have command queries, responsibility, segregation, and where we have DynamoDB being our authoritative. So source for the state of our individual I gives us that concurrency, control, isolation, durability, all the things that we want from the operational database. But we also want to able to do something like full text search, for example, with something like Elasticsearch. Okay, and using this pattern allow us to provide the one of the best possible indexing performance for the particular type of query pattern that we have been using. So we are basically able to find such kind of persistence model here, and many of the people are solving this by using a triggered lambda function, as I told you in the previous slide as well. So to read the changes from the DynamoDB, then those to the additional indexes, Redshift is also a common one, and perhaps even to do another DynamoDB table. So AWS has recently announced in preview, the Glue team did a feature called Glue Elastic Views. So which is really mean to solve for this and make these kind of pattern very much easier for the customers whosoever is using AWS. And imagine a complete serverless code-free solution which you can use on ongoing change data from your DynamoDB to S3. Isn't that beautiful? So that's come with some operational filtering and transformation. And this described that using again particle, so that going to feel a lot like the view we are providing and secondary index in the complete different indexing technology. Okay. So that's the purpose built for your query. Needs super excited about the glue elastic view, which you will see in upcoming days, and please go check it out and take a look at the preview. The preview is already available by the by AWS. Now moving in there. So the last thing, one more thing which I want to touch on quickly is what we can do to help developers innovative, making them innovate, make them think faster, how they can do, how they build on the DynamoDB NoSQL bench in a standalone. So graphical tools for Windows, Mac and Linux available to download from AWS and use at no cost. That's free for the developers. So when building a solution around DynamoDB, the Workbench helps to understand your data and data operation and allows you to relatively refine your data model for optimum multiple results. So it is composed of three sections: the data modeler, the visualizer, and the operation. Okay, so the builder in the data modeler, you define your schema for DynamoDB, and the relevant schema elements are those that you will index around. And you describe your indexes, the base table and the secondary indexes. Then you go to the visualizer, insert some example items, and see how they look from the perspective of each index. While developing your design, you will likely go back to the data modeler several times to refine your indexing, so it will not stopping you. This is an iterative process made very much easier by Nosql Workbench. So when you think you are okay with your design, you can commit your visualization and the example data to the real DynamoDB table. So this is then enables you to use the operation builder and to easily construct your data operation using a graphical interface. And then you can test them against your DynamoDB and generate the snippet of code that you can copy as a template from your own software development. And this approach to building on DynamoDB is very productive. And I highly recommend you that builder can use it as a basis of your DynamoDB. It's a graphical tool available online. So let's talk about let's talk about some of the less obvious way that I'm seeing the NoSQL Workbench deliver business value. Here we see a screenshot from the visualizer. It's an online bank scenario and that I have used to demonstrate DynamoDB transactions. And now when you talk about the first thing you want to point out in here, the button that allow you to commit in. So an example and indexes into and DynamoDB. So this not only enables the operation, the first one, builder as a next developer step, it also allow us a very easily create a live environment to testing or for demonstrating a data model we are proposing. So using the console CLI or SDKs, you can download in here. And next I want to point out the import and export. This is the import and export, which is top left. These allow us to save out our data models and example data as a simple JSON file. So this can be shared so that people can collaborate on the design and suggest any changes. It can be saved as a documentation. So years from now, when the development teams have changed, this will be easy to import to NoSQL Workbench to understand the models and perhaps to involve the design to support a new feature in your application. Um, while we are finally talking about in the export to PNG button, this allow us to easily snapshot the various view of our example data through our indexes again. And this is terrific for demonstration and documentation. So when working with AWS development teams, the external customer to review the DynamoDB design, they will use this tool to priceless team, use this to develop a proposed model, they share it with the others for review, and they save the design out for future reference. Okay, so this tool unblocks DynamoDB design and encourages the right way for getting great result from the DynamoDB. So I cannot recommend it enough. It's changed most of my life as well. So this was all about things over here. And these are some of the resources. Let me copy paste them for you in a chat window. Give me a minute. Let me get into there. And let me copy paste. Give me a minute. Sorry, guys. Let me pick up all the I'm giving you all these links over on the chat window, which will really help you. See if you are able to get those. And thank you guys. Thank yous for joining us again. Um, thanks. You can get in touch with us while following us on LinkedIn and Facebook. You can drop us an email if you are looking for something new from us. So